Hello, and welcome to Partially Redacted, a podcast where we discuss privacy and security engineering and related topics. I'm your host, Sean Falconer, and today I'm joined by Arvind Raghu, Principal Specialist in EC2 and Confidential Computing at AWS, and we'll be talking about confidential computing in AWS Nitro Enclaves. Arvind, welcome to the show.
Hello, Sean. Thanks for having me here today. Absolutely excited to be talking about confidential computing. It's a topic we want to get the word out on as much as we can. Very, very excited to be here to discuss it further.
Yeah, absolutely. This is a topic that has come up a number of times in past shows when I ask people about, what technologies essentially are they excited about. So I'm really looking forward to learning more. I think the audience is going to learn a lot. Maybe before we go too deep, let's start with some basics. Can you introduce yourself, maybe share a little bit about your educational background, work history, and how did you get to where you are today working in this particular area at AWS?
Sure. I'd be happy to do that. Let me start by sharing a little bit about my background here. I'm originally from a coastal, beautiful city named Chennai from South India. I have a master's degree in electrical engineering from Arizona State University and an MBA from UC Berkeley. I've worked in the tech industry for a little more than 20 years now. I have a product background, so prior to doing this job, I spent a good part of 20 years just working on products. I have journeyed through the entire value chain, if you will. I spent most of my early years in the semiconductor industry. I had the opportunity to work on a variety of different products. Started with memory, worked on storage, worked on co-processors, accelerators, and the last stint I actually did was on compute accelerators, which is what really drew me to the cloud and AWS as well. And AWS culture of innovation on behalf of their customers really resonated very close to my heart. And that's what brought me here to AWS. In this role, I work very, very closely with customers. And that's really where I moved to the other end of the value chain, from having developed products to actually seeing how they get used by our customers and how we can innovate better on their behalf. At AWS, I'm responsible for the confidential computing business with a focus on the Nitro system, Nitro Enclaves, and Nitro TPM. I'm really thrilled to be here and to talk about AWS's perspective on confidential computing and some of the differentiated capabilities that we offer, such as Nitro Enclaves.
Yeah, that's awesome. That's a really succinct summary of 20 years of experience. I've also kind of moved around followed a similar path in terms of the value chain. Although I never worked in hardware explicitly, but I started out very much in sort of hardcore engineering, and it has moved gradually throughout my career more and more to the customer side of the business. So I think you kicked us off at a good spot there to start to dive into this topic. I think an obvious place to start this conversation for those that are like completely uninitiated, what exactly is, confidential computing?
Sure. Confidential computing is a term that could mean different things to different people, depending on who you talk to. At AWS, we define confidential computing as the use of specialized hardware and associated firmware to protect customer code and data while it's being processed from any unauthorized access. Upon speaking to customers, we have identified two distinct security and privacy dimensions of confidential computing. And dimension one is one in which customers want to protect their code and data from operators on the cloud provider side. In this case, that would be us, AWS. And dimension two is one in which customers are looking to protect their most sensitive code and data, even from privileged users on their side or malicious actors who could pose as privileged users from their side. So to put it, succinctly, confidential computing is about protecting data while it's in use from any unauthorized access. That's really all it is about. Now, the dimensions could vary. It could pertain to who you're protecting it from. Is it from us or from you? And those are different aspects of confidential computing itself. But the key to focus on here is it's about protecting data in use. Let's take a simple use case to help people understand what this is, right? Let's take, say, something like ad tech as an example. A lot of social media companies and publishers have access to data that is considered to be personally identifiable. They could know a little bit about you, they could know a little bit about me. Now, there is definitely a lot of impetus and desire to maintain data privacy in that space, even as all of these enterprises aim to publish, say, personalized content to you or me. In that scenario, Encrypted data could be brought inside a Nitro enclave and then further tokenized inside the enclave to ensure the identity of the individual is not revealed to anyone. These anonymous tokens can then be exported outside the enclave and can be used, to publish personalized content, if you will. In this case, you can see when they utilize a capability like enclaves, they're really protecting your data. They're really making sure that it's not just about data protection, it's also a little bit about privacy there as to what they're doing with the data and where they are handling the data. So that's really one of the use cases to think about if you're trying to wrap your head around where confidential computing is applicable.
Yeah, I think this is, the idea of essentially securing or protecting data while it's in use is something that, in some ways, as someone who's been in the computer science field for a long time, feels like science fiction, where we're used to encryption at rest, we're used to encryption during transit, but the holy grail there is, well, when we actually use it, we don't want to risk essentially exposing the data. And in that use case you talked about being able to basically bring encrypted data into the enclave and then perform sort of tokenization or some other type of operation against it securely within that environment, essentially insulates or protects everything else from ever being exposed to that data and allowing you to actually use it in a really essentially be able to securely use the data and unlock this science fiction use case that we've all dreamed of for a long time.
It's reality now. It's not science fiction anymore.
Yeah. What are the some of the problems, I guess, this approach to privacy and security solves that were potential vulnerabilities to companies in the past? Obviously, if you have to decrypt data in memory, that is a potential exposure. But are there other sort of privacy security use cases that this helps address?
Absolutely. There's a variety of those, but let's first focus on what are the problems that this approach to privacy and security solves, right? That's the first part of the question there. And the first thing our approach solves for, as you pointed out earlier, is protecting data in use. The mechanisms to protect data while it's at rest or while it's in transit has existed for a while. It's pretty mature and pretty well documented. But then extending that protection to make sure data remains protected while it's in use is has been a big pain point and a problem that's been asking for a solution. And that's what this really solves for, right? It extends the protection customers are already getting from protecting data at rest and in transit and moves it into that frontier where it protects data in use. The second huge benefit from an approach such as Nitro Enclaves or overall the confidential compute solutions that we provide is to ensure that no unauthorized access is allowed for any sensitive code and data that runs in a secure, isolated environment. Protecting the data from yourself was not a mechanism that was readily available prior to this. You could still do it without a feature like enclaves, but it was just a lot of heavy lifting from your end, and it was not really suited for everyone. You could potentially create, say, a dedicated VPC or remote all network access, implement really fine grained controls, but then have to maintain all of these controls yourself. That's a big heavy lift and operational overhead, if you will. The intent, the impetus, the mechanisms, they were always there to protect data. But what Nitro Enclaves did was brought that to life with the ease of implementation that it provides. So that's really what it was solving for. We could also take the example. You could pivot this from a customer perspective, from a use case perspective, and look at it and see what it solves for. Right? Let's take a use case like multi-party collaboration. Let's take a case where there are multiple parties with data, sensitive data sets about something in common. Maybe it's about me, and there are two different parties that have data about me. Now they have the opportunity to put together this data in an environment like Nitro Enclaves, where the two data sets could be pulled together to draw meaningful inferences about me without ever having to share the data set with one another. That's the most important thing. You have sensitive data about myself, somebody else has sensitive data about myself, and you could potentially draw inferences about me without ever having to share the data with each other. So these are use cases that were not enabled prior to this very easily. Nitro Enclaves and confidential compute as an environment provides the organic building blocks that let you do this very easily. Those are the problems we are really solving with something like this.
So you mentioned this idea that it prevents essentially like unauthorized access to the environment. So how does it exactly does that work? Like how does this like hardware based trusted execution environment prevent like a bad actor from getting in there and doing something malicious?
Sure. Before we discuss that, let's unpack your question a little bit, right? There are the most important thing to remember here is yes, it's a trusted execution environment, but it is not necessarily hardware based, or it's not only hardware based. Let me put it that way, right? Why would we restrict our discussion to say a hardware based trusted execution environment? The approach that we have taken at AWS to solve customer problems in this space includes a mix of both hardware and software capabilities. And for that reason, I would like to address this as a trusted execution environment as a whole and not just a hardware based trusted execution environment. To begin, I think we have to baseline where we are when we say trusted execution environment or even confidential computing, if you will, right? By design, at AWS, if you're using any of the EC2 Nitro hosts, there is no mechanism for any system or person to log into these EC2 Nitro hosts. There's no access to memory of these EC2 instances, or there's no ability to access any customer data stored on a local encrypted instance storage or a remote encrypted EBS volume. So, from a trusted execution perspective, if you really look at how we have architected our Nitro system, and if you look at the security design of the Nitro system, for all of these EC2 hosts, there's just no operator access. If any AWS operator, including those with the highest privileges, need to do even any maintenance work on an EC2 server, they can only use a limited set of authenticated, authorized, logged, and audited APIs. None of these APIs provide any operator the ability to access customer data on the EC2 server. So at a baseline, we have to understand that from a trusted execution environment perspective, we are providing that protection by default. Extending that protection even further is the EC2 feature Nitro Enclaves, where we provide an isolated environment with no external connectivity, no persistent storage, and no root user access. The only connection the enclave has is it's to its parent instance via a secure local channel. In addition to this, the enclave can also provide proof of its identity. It can attest to itself. It can attest to its identity and that of the specific software that's running inside the enclave. This is the software that's intended to process this sensitive data, and the enclave can attest to the integrity of that software and authorize only that piece of software to run inside the enclave. This capability is in place to ensure that there is no malicious actor trying to run something that you don't expect to run in an enclave. This is what the trusted execution environment provides. This is how we protect that space.
I see. And then what is the process of using a Nitro Enclave versus using like a standard EC2 instance as an AWS user?
The process to use an enclave is actually pretty simple, right? Nitro enclaves are actually essentially carved out from your standard EC2 instance. So what does that mean? If you already have an EC2 instance running today, and you are faced with a workload that, let's say, you have to split into two parts, a untrusted and a trusted part. The trusted part of that code is what really is expected to reside in an enclave. That's the one you want to protect, because that's what's going to process all of this highly sensitive data that you're going to bring in as payload inside the enclave. Now, to do that, all you have to do is dedicate CPU and memory resources from your existing EC2 instance and launch an enclave. And you can do this with three simple steps. Step one is to launch a compatible Nitro based EC2 instance. And when you launch it, you have to set the enclave's option parameter to be true. Step number two is to use the Nitro CLI, which we provide, to convert your Docker image into what we call an enclave image file. And step three, using the enclave image file as an input, create the enclave using Nitro CLI. It's as simple as that. It's a 3-step process, and the enclave itself is getting carved out from your EC2 instance. So there's nothing special you have to do except go check that flag when you're launching your instance from the console.
Okay, so once I have this set up, how do I go about using the enclave to perform like an operation on sensitive data? Can you walk me through like what that process looks like? What is the like, I don't know, the execution or programming process to actually do something like that?
Yeah, sure. You know, the first thing to understand and also inform the listeners here is Nitro enclaves are actually full-blown virtual machines. They have their own Linux OS. So if your application runs on, say, EC2 Linux today, it should just as easily run inside an enclave. And to raise the security bar, the network access has to be specced out and built purposefully using VirtIO vSock, which is the secure local channel that connects the enclave to the parent instance it was carved from. There's no persistent storage, which also means that the results of the processing have to be sent out of the enclave, always making sure only encrypted data leaves the enclave. So these are all some basic considerations to remember when you're trying to use an enclave. The programming process itself does not look any different from what it does today. You could just as easily build an application, drop it inside an enclave, and go through the attestation process for it to execute. The considerations of using an enclave, however, need to be clearly thought through when you're trying to protect sensitive data while performing an operation on it. And the specific needs, such as, say, if you want to produce reproducible builds or whatnot, you have to keep those in mind, because when an attestation process has to be followed, certain measurements that pertain to the enclave and the application that runs inside it are signed into what's called an attestation document produced by the Nitro hypervisor. So this attestation document is going to be used everywhere else for the enclave to be able to attest to itself. So there are certain considerations you have to keep in mind as you build your application. And one of the most governing rules that we always recommend as a best practice is the surface area, attack surface area that you're concerned about has to be kept to a minimum. And to do that, we have created a very isolated and hardened virtual machine for you to work with, which means there's no external network connectivity or there's no storage in place. So if you're trying to repurpose APIs that you have in place today and try to drop that inside an enclave, those are some of the considerations for you to think about. It's always good practice to go back and check if you have any external network calls you're making, if you have storage calls you're making. And lastly, you have to remember that if you have a really large code base, you'll invariably require some observability which needs to get built in, which we also recommend you keep to a minimum to avoid any inadvertent data exfiltration from the enclave. And that's the whole point. You want to keep the data contained inside the enclave. You want only encrypted data ever to enter or leave the enclave. So you have to be careful about what you're architecting for, and also make sure the observability component that you're building into it as you increase your code base within the enclave is kept to a minimum. So those are the considerations I would say you have to think about from a process perspective. From a programming perspective, it looks exactly the same. There's just no difference.
Mm-hmm. Yeah, so it sounds like it takes a little bit of thinking from a process perspective, but well worth it if you're dealing, especially with like highly sensitive data from like financial information, healthcare information, or something like that, where data protection is really core to like probably the promise that you're making to your customers in that case.
Exactly. And that's why I said you have to be very purposeful about what you're doing, right? Not all data is created equal. And so not all data needs to be processed inside an enclave. You have to think about what really goes inside the enclave. What is it you're protecting and who is it you're protecting from? And that's going to drive the solution you're building. And that's going to drive all the other decisions you're making around which is going to be a trusted component that resides inside something like a Nitro enclave, and which is going to be the untrusted piece that can run in a standard EC2 host.
Hey, it's Sean, host of the show you're listening to. First and foremost, I hope you're enjoying the interview. And if you are, please support the show by subscribing and leaving a positive rating and review. And if you want to keep the conversation going, join our community at skyflow.com/community. Okay, that's it for me. Now back to the show.
Yeah, I think that point you made about not all data being created equal is something that is really, really important for anybody who's doing, building systems today to understand that some subset of your data is special and it needs to be treated specially. And maybe that's within, an enclave, but is not, you're not going to put your entire code base and your entire database into the system because it just doesn't make sense, but it makes sense for certain classes of information.
Exactly. You said it better than I did.
So obviously there's a lot of different use cases for Nitro Enclaves. What are some of the use cases that you've seen or heard about that you're particularly excited about?
Sure. One thing to keep in mind as we talk about the use case, right? We are not restrictive in terms of being a general purpose VM, right? Any use case where there is a need to protect sensitive data or even code in an isolated environment would be a good candidate for running inside an enclave. So that's just some high level concept to keep in mind, right? And when you think about operations that you're performing inside an enclave, it could range anywhere from, say, cryptographic operations like decrypting data inside an enclave, or signature validation, signing transactions, tokenization kind of operations, masking, right? If you're running a credit card related transaction and you want to mask some of that data, you could be masking some of your data inside an enclave. Inferencing, if you have say models that are already trained and you have data sets that you want to process with that model, you could drop both of them inside an enclave and run some inferencing kind of operations. So there's a variety of different use cases which all are processing sensitive data that could run inside an enclave. Let's take a few examples, right? Let's first take a use case that I really like to talk about, which is about actually protecting code and not necessarily only data, right? So machine learning models. Let's say you're a provider of a machine learning model, and that's really the secret sauce that you're looking to protect, right? But you want to license it out so you can monetize from the model. You've already trained the model, and I have a need to use a model, and I have my own data set that I want to use. Now, what we both can do potentially is for you to drop your model inside an enclave, and I could drop my encrypted sensitive data set inside the enclave and use your model to draw inferences on my data. We both benefit from collaborating here, but your code always remains protected because it's never visible to me, and my data remains protected because it's not visible to you. Right? So this is a collaborative use case where both code, in this case, the machine learning model that we talked about, and the sensitive data set are being protected inside an enclave, but also where the data is securely being processed to draw some inferences out of it. Just one use case where more than data is getting protected. This is a use case where you're protecting IP, right? Let's take another segment altogether, right? I'll just go all the way out into blockchain world, right? There are a lot of different use cases in blockchain where something like Nitro Enclaves is very, very pertinent. Let's take blockchain bridging as an example. There are multiple chains, multiple public chains that are being used today. Now, data could move from one chain to another, but when you're moving data or assets through different chains, you have to go through nodes. Now, when they move from one type of chain to another type of chain, they have to go through a bridging. And this bridging is actually happening off chain. And this is a use case called blockchain bridging, where now transaction needs to happen or data needs to get manipulated and moved around. And that has to happen in an isolated compute environment, such as Nitro Enclaves. So that is a great use case where we could move data between chains, and it's happening in a node that's off the chain, where you have a requirement for an isolated compute node. Another use case in the blockchain world would be hot wallets, right? Hot wallets are where digital assets are actually getting transacted actively. They're not just in storage, but they're actually getting transacted. Ownership changes are happening, asset changes are happening, right? And that's another use case where enclaves are highly applicable and pertinent, because you could securely run your transactions inside an isolated compute environment like enclaves. Another use case within the same realm would be a signature validated node, if you will, where multiple key shards could be brought in, validated, and the shards could be put together to draw consensus. So a specific transaction can be approved or not approved depending on the result of the consensus. So these are some use cases, say, in the blockchain world. And then I think we when we started earlier, we talked about a little bit about data privacy and protecting, say, personally identifiable information, whatnot. So in that scenario, you could be creating tokens for personally encrypted, personally identifiable information that gets dropped inside an enclave, gets decrypted in an enclave where plain text gets revealed. But now you don't want to exfiltrate this plain text ever anywhere else. So you could actually tokenize that and then send it out. And a good example that I would like to showcase here is UID 2.0, which is a tokenization application that was developed in collaboration with the Trade Desk. We actually blogged about it too, and be happy to share it with you later. And this was a use case where Trade Desk actually created this token, which the tokenization app itself runs inside an enclave. And then the token is the one that actually gets sent out, so ad publishers can use that to publish, personalized content, if you will, to users. And then the last big group example group I would use here is multi-party collaboration, right? I'm sure you've heard of these different technologies where they talk about trusted research environment, privacy enhancement technologies, and whatnot. These are all multi-party collaboration use cases, if you will, where multiple parties could potentially bring their own data sets, which can all be dropped inside the enclave, pulled together to make certain computations without the different parties ever gaining access to the other party's data. United Nations Privacy Enhancement Technology Labs actually ran a hackathon, I would say about 2 or 3 months ago, where Nitro Enclaves was actually used as the beachhead technology to operationalize use cases such as multi-party collaboration. Right, at a very high level, if you think about the implications of something like this, if you have say trade reconciliation that needs to happen, say between multiple governments, right, and none of the governments want to share data with each other, that's really a classic use case where you could put all your data inside a secure environment which nobody gets to peek into and process that data, right? IP protection is another one. Data marketplace, identity verification. I could just go on and on, but I think at a very high level, you probably got a good smattering of different use cases that are applicable here.
That's a really interesting use case. With that, you had mentioned UID 2.0 a moment ago. Can you provide a bit more information about what that is for those that are listening and don't know, or perhaps maybe relate it to something the audience might be more familiar with?
Yeah, absolutely. I mean, it's good to provide some background on a new topic such as this. So, advertisers have traditionally relied on third-party cookies, if you will, to deliver tailored advertising to consumers. But more recently, as we both know, the advertising industry as a whole is facing the need to reduce its reliance on cookies and identifiers in favor of increasingly protecting consumer privacy. And to that extent, I would say, cookies are going away, right? There's a new push to improve how to identify consumers and deliver personalized advertising in a trusted manner to your consumers. UID 2.0, which is Unified ID 2.0, is a new industry solution designed to address this opportunity. It's been developed by the Trade Desk, and it's a non-proprietary open standard actually that enables ad publishers selling advertisement to continue to deliver personalized advertising to you and me without ever having to use third-party cookies. That's really what it is. It's a replacement of third-party cookies, if you will, to publish ads to you in a very trusted manner without identifying you.
Awesome. Yeah, I mean that's really interesting. Given that I think the idea of a cookie was developed quite a long time ago, so it probably needs a refresh at this point.
Evolution.
Yes, exactly. Yeah, I mean, I could even imagine a scenario where you have two businesses that are considering merging or an acquisition in some case, and they want to see how much customer overlap do we have, but they don't want to reveal who their customers are. And essentially, you can bring those records into the enclave and do that compute without actually, sharing essentially those records.
Absolutely. Absolutely. I mean, think about two businesses again. I mean, because you gave that example, right? Maybe there's a little bit of a bidding going on, and there's a neutral party that would get to see the bidding, but neither party who's actually doing the bidding should be able to see any of the numbers, right? Just another example right there.
Yeah, we did a show a little while ago on secure multi-party computation, and we talked about Tao's millionaire problem, where essentially you have a bunch of millionaires that are sitting around at lunch, and the person with the highest net worth is they decide is going to pay, but they don't want to share what their net worth is with each other. So how do you actually solve that problem? It sounds like we can essentially do that today using Nitro Enclaves as a solution to that.
Oh, maybe I should do that when I go to lunch with my colleagues.
Yeah, exactly. So whenever you're at lunch with your super rich colleagues and you want them to pay for lunch, whoever has the most money, you can just run that through an enclave and you're all set.
It's a good example, Sean.
Yeah. Are there any limitations or trade-offs to consider? And we touched on a couple of these things earlier, but when actually making the decision to use Nitro Enclaves for some form of confidential computing, what are some of the things that people need to think through?
Well, limitations, trade-offs, these really come down to the use cases that you're dealing with, and also comes down to what it is that you're really looking to achieve, right? From a performance perspective, the enclaves are carved out of your standard EC2 instance today, so they are actually as performant as what your EC2 instance would be, right? Because they're coming out of the same instance. So that's really not something that I would say is a consideration. The real considerations are, what are you really trying to protect, and how much of that how much of that payload are you really carving out and dropping inside an enclave? And if you have, say, APIs that you have today, you're trying to repurpose in this scenario, um, the active choices that you have to make about dropping existing code inside an enclave, and how much of that refactoring really are you going to go and touch, right? That's really what I would say is the consideration to look into more deeply. These are the choices that you're making, right? There are always considerations to take into account when adopting something new. There's just no questions about it. But the most important thing is, where are you starting from? Are you trying to repurpose something? Are you trying to build something new? If you're trying to build something new, it's a lot easier go, because you have the rules in place and you know what to build for. If you're trying to repurpose something you have, that's when it starts to get a little bit tricky, because now you have to make choices about, what am I going to split and drop inside an enclave, what am I going to keep outside of it? And when you do that, how much of refactoring are you really going through? Those are the things that I would say you have to keep in mind. Those are the trade-offs to consider.
Mm-hmm. Yeah. And I think you highlighted a really good point that I'm glad you brought up, which is that this is actually performant. So you can actually use this in real applications versus another technology that people think of when they think about doing, operations on fully encrypted data is homomorphic encryption, which has the downside of not necessarily being performant and enterprise grade for all general use cases today.
That's exactly right, right? Like, I mean, it's a forward-looking technology, if you will, for it to operate at scale. What enclaves provides is actually an isolated environment. So you could bring encrypted data inside the enclave and proceed to safely decrypt it and reveal plain text, and then process plain text, which we know how to do pretty well right now with the CPUs that we have in place.
Right. So historically, I think we've seen security often be like an enabler for innovation. For example, without public key encryption, we probably don't have online purchases and e-commerce and Amazon essentially. So it's easy, I think, to overlook some of the potential like economic or innovation impact that a breakthrough in security can have. What innovations or business directions do you think secure enclaves will enable in the future?
I think we talked about the use cases that they're already enabling, which were not possible prior to this, right? But the most important theme for me in the future, say the next 5 years or so, I expect confidential computing to be ubiquitous in the cloud, right? I expect it to be just prevalent, something that you should take for granted as being available for you, which we already do to a great extent from an AWS perspective, because when you use a Nitro-based instance today, we are already providing protection from this dimension one, which we talked about, where you're protected from operator access completely by default, right? Where I expect things to head in the future is for all different aspects of confidential computing to be ubiquitous and available for you to just choose from. It'll just be up to the users to choose the varying degrees of access and data protection that they're really looking for, depending on what they're trying to achieve. But it'll all just be available, taken for granted, if you will. That's really where I think it's headed in the future. That's my personal opinion, but yeah, that's what I think.
Yeah, I mean, I think that's kind of, if you look at something like TLS, that's basically where we are with that. Like, people take for granted that now every website that you basically go to is HTTPS, but there was a world, 10, 15 years ago where that was not the case, or it would only switch to that when you were about to put in your credit card information, rather than, every single page that you're hitting essentially protected by that and having encryption during transit. And now we just kind of take that for granted, and that's, the default experience for everybody.
Absolutely. And things will evolve, right? I mean, today we're talking about, hey, if you want to split it, these are the rules you have to follow, and this, you have to make trade-offs between what goes in there and what doesn't, and all of the refactoring considerations we talked about. Maybe all that will go away. Maybe in the future we're going to see it as being built for that already, and much easier to adopt.
Mm-hmm. Absolutely. So what's next for Nitro Enclaves? Is there anything that you can share?
This is an easy one to answer always, right? What's next for Nitro Enclaves is always what our customers want. We firmly believe in working backwards, from our customer requirements, and we build all our products based on that. So we are having these conversations, as we speak. Even now, the perspective of this question and the more direct answer to you is, I'd love to have the opportunity to come back to your show and share what's new from our side, right? It's customer requirements. We'd love to hear from you. We'd love to hear from our customers, and that's really what gets built. That's what I would say is new.
Yeah. So if you're listening to this and you want something built, reach out to
Yeah,
Arvind.
reach out to me. Yes.
Yeah. Awesome. Anything else you'd like to share at this time?
Yeah, I think one thing I would definitely like to close out on is focus on AWS. AWS's customer obsession here a little bit, right? When we designed Amazon EC2, we understood that our customers would want to have their data protected at all times. We designed our entire network from the ground up with that in mind. That included the physical protection of our data centers and any work our customers do using our systems from being accessed by any AWS operator or employee. This initial choice made some of our initial development harder, but that also made us think and innovate more. That constant pace of innovation, listening to customers, has really allowed us to continuously improve our security for our customers and deliver features such as Nitro Enclaves. We continue to listen to our customers and believe our experiences will help us design the future. I'm really excited for what's next, even more than what we've already delivered. As a technologist, and I think Sean, you'll agree to this, it's always really powerful to think about how we improve on what we've delivered for our customers. That's really what's going to move the needle for them and for us. That's really what I'd like to close out with.
Yeah, I think that's a great point. And I think anybody that's building any kind of product, ultimately you want to have people actually use it and enjoy using it. So it's, we don't, anybody can build something in a silo and just use it by yourself. But the exciting part is when actually you see people using your work and enjoying it. But anyway, Arvind, thanks so much for doing this. I learned a ton. This is such an exciting area, as we talked about at the beginning of the show. It's amazing to see technology like this actually coming to market and enabling these new use cases, and hopefully having a positive impact on the privacy and security posture of new types of applications. So thanks again for being here, and cheers. And we'd love to have you back in the future to talk about some of the changes that actually have happened.
Absolutely. I'd be excited to have to be back on the show. And like you said, the positive impact is what we're all looking for. We're already seeing that in the market today, and we'd like to see more. Thanks, Sean.
Thanks.